In this video, we're going to learn about polymorphism and how it affects assigning objects to variables. In Java, every object has a type. The type of an object defines what that object is. Cat objects are cats, dog objects are dogs, and string objects are strings. The statement cat Tom equals new cat instantiates an object of type cat and assigns it to a variable that is declared to hold cat-type objects. The variable Tom and the cat object are two separate things. The code cat Tom created this variable and declared that only cat objects may be placed inside it. The code new cat created this cat object. This object is a cat. Cat variables, like Tom, can hold any objects that are cats. But if you create another object that isn't a cat, it can't be assigned to this variable because it's a dog, and this variable can only hold cats. The variable type restricts what objects can go in it, and the object type identifies what the object is. Objects can only be assigned to variables if they have a matching type. But what if you want a variable that can hold a cat or a dog? How can you assign two differently typed objects to the same variable? Polymorphism. Polymorphism is a fancy word that means many forms. In Java, this is referring to the fact that objects can have more than one type. When a class extends another class, it creates a class hierarchy. Each class can be used to create an object of that type. A fruit object is a fruit, and a tomato object is a tomato. But since the tomato class extends the fruit class, it also is a fruit. It has two forms, tomato and fruit. In fact, it has as many forms as it has ancestors. If fruit extended another class, then a tomato would be a that type of object too. A fruit object is a fruit and a food, but not a tomato, because objects only inherit types from classes above them in the hierarchy. You can see why this is the case if we add a cucumber to our hierarchy. Clearly, a cucumber is a cucumber, and it also is a fruit, and it is a food, because fruit and food are above it in the hierarchy. If you make an object from the fruit class, it is a fruit, and it is a food. But what kind of fruit is it? Is it a tomato or a cucumber? Yes. A fruit could be either a tomato or a cucumber, but it isn't either. A fruit object could be any fruit, even a boat. All we know is that it is a fruit, which is a food. Remember, we are trying to answer the question, how can we declare a variable so it can hold either a cat or a dog type object? Whatever type we declare the p variable will determine what type of object can be assigned to it. A cat is a cat type object, so it can only be assigned to cat variables. And a dog is a dog type object, so it can only be assigned to dog variables. If we want to be able to assign both of these objects to the p variable, then they both need to be the same thing. They need a common ancestor that they can inherit a type from. Let's call it pet. A cat still is a cat, and a dog still is a dog. But now they are both pets. So cats and dogs can both be assigned to pet variables because they are both also pets. Polymorphism gives us the power to declare one variable that can hold different types of objects. We will explore how we can take advantage of this power in future videos. For now, remember, variables can only hold one type of object. Objects can only be assigned to variables that match their type. Objects inherit types from classes above them in their class hierarchy, and objects can be assigned to a variable that matches any of its types. And that is computer science.